Hey scientists, it's Mr. Crouch. Welcome to the second session of measuring mass. In the first session, you learned what mass was, you learned about some metric units for measuring mass, you learned about some science tools for measuring mass, and I showed you how to use a pan balance. Today I'm going to show you how to use a triple beam balance. This is a triple beam balance. But before we get started, let me show you how to carry a triple beam balance. You carry it either like this or from the bottom. You never carry it by the beams. Well, anyway, it's called a triple beam balance because it has 1, 2, 3 beams. Triple beam. Now, the first thing you need to do is bring all the beams to 0, all the way to the edge. And when you do that, this pointer here should point on 0. If it does not, you'll have some fine tuning to do. This here is an adjustment screw, and if you turn it, it should bring it either up or down to have it align on 0. So getting back to the beams, first of all, a triple beam balance measures in grams, and we learned that in the last lesson. So the biggest bar goes from 100 to 500 grams. The back weight goes from 0 to 100 grams, and the front one goes by the ones, and it has tenths of a grams in the middle. So the first thing we need to do is find out something to measure. Let's find the mass of this Zephyrhills bottle. Hey, maybe Zephyrhills will give me some money for advertising here. Zephyrhills, that's good water. I think I'll stick to science. Anyway, so I put this in the center of the pan. And I start with my biggest beam. And it's very important, there's these little notches here. And when you move the beam, it must click. So I moved it here. That's 100. Well, it didn't do anything. Move it to the next one. Click. 200. Click. 300. So it's on 300 grams, but that's too much. So I must move it back. So I'm going to put it to 200. Now I adjust my tens. So here's 10. Click. 20. 30. 40. 50. 60. Oh, 70's a little too much, so I need to bring it back to 60. Okay, so for the front one, what you want to do is probably use a pencil to move it. So I'm going to get started. So I'm using my third hand now to move this bar here. Actually, I have an assistant. So he's moving it very slow so that we want to line it up. So he's just past the 8, up to the 9, and now he's going nice and slow. Let's give it a second. Let's see if it lines up. So there we are. So now we'll do the adding. So right here, we are on 269, but it's past the 9. Now there's 10 lines between each one. So each little line represents 1/10 of a gram. So it's 9.2. It's on the second line, 9 2/10. So let's add it up. Okay, so we measured the mass of the water bottle. Let's look a little bit closer at the beams here so we can get the exact mass of the water bottle. So we're going to go to the biggest beam first, the hundreds beam, and we see it's on 200 grams. So write down 200 grams in your journal, and we're going to add this all up. Then we go to our tens. We see the back beam here is on 60, so write 60 and line it up like you're adding it. And then we see our front beam. It's just past the 9, so you have 9 in the ones location. And then you see it's on the second line. There's 10 lines between each whole gram, so each of these little lines is worth 1/10 of a gram. So it's on the second line, so it's 2/10 of a gram, so it's 9 2/10 grams. And we're going to add this up. So when you add up your tenths location, you'll get 2. When you add up your ones location, you'll get 9. When you add up your tens location, you'll get 6 tens and 2 hundreds. So the total is 269 2/10 grams. Make sure you label everything. And that's the mass of the water bottle. We're going to practice more with the reading of a triple beam balance, and we'll make some predictions. Okay, we're going to continue practice reading a triple beam balance. So the next object we're going to measure is an apple. So write down your prediction of the mass, And I'll go ahead and show it to you on the scale. Okay, here's the apple on the triple beam balance. We see that it's balanced correctly and it's lined up with the 0. Let's get a closer look. Okay, so here's a close-up of the scale. So go ahead and look at all the bars and write down the mass of the apple based on these bars. I'll give you a moment and please pause the video. Okay, did you write it down? All right, let's see if you were right. Well, the first thing you should have done is gone to the hundreds bar, and you see that it's lined up on the 200, so it's 200 grams. And then we go to our tens, which is in the back, and it's on the 40, so line that up. Then we go to our front, and we see that it's between the 3 and the 4, but it's past the 3. And it's on the middle one on the 5th line past the 3, so it's 3.5 grams. Then we're going to add those up. And if you add them up, you will get 243.5 grams. All right, were you close? How was your prediction? Did you get the answer right? Okay, so let's do one more prediction and let's read the scale for one more object. For the last object, let's do a PS4 controller. Now, how many of you have actually held the PS4 controller more recently than you've held an Apple? And that's what I thought. All right, so let's write down your prediction. Okay, so we have the controller on the pan and we see that it's lined up evenly here. So, all right, so let's get a closer look and then you could read the triple beam balance. Okay, so look at the masses and write down what you see. Pause the video and then we'll go over it. Okay, let's see how you did. So go to the hundreds grams bar first and we see it's lined up with 200. So we'll bring over our 200 grams. Then we go to our tens bar and we see it's on the 60. Then we go to our ones bar. We see it's past the 9, and it's on the second line, so the second tenth. So it's 9 2/10. We're going to add it up. And when you add it all up, you get 269 2/10 grams, 269.2. How'd you do? I hope you learned a lot about measuring mass. If you have any questions or comments, please email me overthetopscience@gmail.com. And if you ask a question, hey, I might even read it on my next video. Thanks, and have a great day. Happy science, everyone.